In this lesson, we talk about sampling and camera samples, basically what is sampling and how it works. First of all, let's open up our render settings window and make sure we have Arnold as our render engine. And in the main tab, we can see the sampling section. As we know, Arnold is a ray tracer or a ray tracing renderer, and sampling and ray depth are the very core of Arnold as a ray tracer. That's why we start this course by discussing these principles instead of talking about lighting and shaders, because without having a solid foundation about sampling and ray depth, discussing other subjects would be obsolete. So when trying to render an image, Arnold needs to know the color value for each pixel so it can put together the pixels and give us the final rendered image. In order to do so, Arnold fires a number of rays from the camera. They hit different objects and surfaces in the scene. When they hit something, they calculate the information on the surface and return some information about this object, and this process can be loosely defined as sampling. Based on how many samples you have per each pixel, the render is going to be noisy or smooth and high quality. Now, we use two main words in this definition, rays and samples. And if I wanted to simply clarify the difference between rays and samples, the difference is that the samples are the number of rays square rooted fired per pixel. Now, the number of these rays fired from the camera can be controlled using our camera AA samples. That AA stands for anti-aliasing, so it can be called camera samples or anti-aliasing samples. So basically, the camera samples control the number of rays per pixel that will be traced from the camera. Camera samples is a global multiplier. The higher this value, the higher the quality of your render is going to be, and also by increasing this value, you're going to increase the render time. Also, remember the actual number of samples per pixel is the square of what you have defined here. For example, if we set our camera samples to be 3 by 3 equals 9 samples per pixel. So 9 here is the actual samples per pixel. You can see in this upper section of the sampling rollout, the actual camera samples is 9. Another thing to consider about camera samples, it is universal. As I said, it's a global multiplier, an overall controller. So by increasing or decreasing this value, you are not only controlling the number of primary camera rays, you also change secondary ray types like diffuse, specular, and transmission, and increase or decrease their quality. We'll be discussing these ray types obviously in this section later on. Now let's see how camera samples can be used in our scene to increase the quality of the render. This is the scene I have prepared for this lesson. If I get out of the camera, you can see what we have in our scene. We have this backdrop, this green sphere that has some very small lines, this reflective clock, and this abstract 3D model with a diffuse material. You can check out the materials I have applied in the material manager, but that is not our concern for now. I have also a few quad lights as our light sources in the scene. You can check out their settings as well. The lighting will be discussed in the next section of this course. Now let's open up our render settings and go to Arnold Render. And let's decrease our camera, diffuse, specular, transmission, SSS, and volume indirect samples all to 1. And let's render it to picture viewer and see what we're going to get. As you can see, because we only have 1 camera samples per pixel, the render is pretty noisy. The small lines and the edges are very jagged, and overall we have a very low quality but fast render. Let me rename this render to something like 1, which is the number of our camera samples, and close the picture viewer for now. And let's increase our camera samples this time to 3. Now, if you take a look at the camera samples, we have 9 samples, because as you remember, the actual samples are this value squared. Always remember the universality of camera samples, and that's why even though we have only one diffuse samples, the actual diffuse samples up here is said to be 9. Basically diffuse value squared, so 1 by 1 equals 1, multiplied by the camera samples squared, which give us 9 samples for diffuse calculation for this render. We discussed diffuse samples in the next lesson. Let me render this to picture viewer again and take a look at the results. As you can see, when you compare this render to the previous one, the overall quality of our render has improved significantly. Not only the edges are less jagged, we have less noise, higher quality GI and specular reflections, and finally, let me increase the camera samples to something like maybe 8 and render it to our picture viewer. Obviously, the render is much cleaner compared to our previous render, but also the render took much longer because we are firing much more rays per pixel compared to our previous renders. So you can see how increasing the camera samples can increase the overall quality of your render in one go. But this is normally not how you increase the quality of the render in Arnold, because increasing the anti-aliasing or AA sample or camera samples not only increases the quality of our primary rays, it also adds more secondary ray samples, like for example diffuse and specular rays. Always remember that when working with Arnold, the picture we have is physically correct. The light rays bounces and falls off like in real world. The only thing we are trying to achieve using these sampling options is how to reduce the noise amount and thus increasing the quality. So we need to find out what is the origin of the noise, whether diffuse rays, specular rays, transmission rays, camera rays, and increase the sampling for the ray type that causes the noise. Also, there are noises obviously that comes from certain effects like motion blur or depth of field. In those cases, you need to increase the camera samples to clear out the noise, and that's the only way to get rid of those noises. We obviously cover noise reduction in one of the future lessons of this course. So in this lesson, we discuss sampling and camera samples. In the next lesson, we discuss diffuse samples. See you there.